Welcome, students. I am Aurora, the artificial intelligence system on SpaceGate Station. In this episode, you will be learning about what drones are, how they operate, and what makes them a special type of flying vehicle. You will also learn about the related concepts of thrust, drag, lift, gravity, and their effects on flying objects.
Commander Collins, are you okay? You seem to be having some difficulty.
Difficulty is putting it lightly. I've been working for the past hour trying to get this drone to fly properly.
What drone?
Processing. A drone, also known as an unmanned aerial vehicle, or UAV, is an aircraft without a pilot on board. Its flight is usually controlled in two ways, either autonomously by computers in the aircraft, which is known as an autopilot, or under the remote control of a pilot on the ground. A drone can be used for capturing images, recording videos, or delivering objects. Drones come in different shapes and sizes, from the size of a large car to as small as the palm of a human being's hand.
No, Aurora, what I meant was what specific drone was Commander Collins referring to?
Sorry, my bad.
I am trying to operate this new experimental Mars drone, but it's not cooperating.
Well, what seems to be the problem?
That's just it. I don't know. The communication links, it's fine. The telemetry data feed, it's operating properly. You know, I have a lot of experience with these types of drones. It's not like I'm flying by the seat of my pants.
Oh no, you did it again.
Processing. Commander Collins, I am confused. Pants are an outer garment covering each leg separately and usually extending from the waist to the ankle. These garments are unable to provide the necessary force to resist gravitational attraction and allow an individual to obtain flight.
No, Aurora. Commander Collins was using another idiom. She did not mean that she has pants that can make her fly, although that would be really cool.
You see, Aurora, if you're flying by the seat of your pants, that means you're using luck and intuition. And then that means you did not properly plan and prepare in order to operate, to fly.
Thank you, Commander Collins. I will remember that idiom for future use.
Well, back to the issue at hand. NASA needs me to get this Mars drone operational so that the Earth scientists can begin their exploration. I need to get this fixed sooner rather than later.
Well, if the communications link is working and the telemetry feed is okay, then it must have something to do with the flight characteristics of the drone on Mars. Perhaps you should contact someone who knows a lot about drones.
Commander Collins, Dr. Schofield is presently in the research lab working on a new drone prototype with Dr. Carafano. Since she has extensive understanding of both computer systems and drones, perhaps she could be of assistance.
That's a great idea, Aurora. You know what? I'll go see her immediately. Specialist Barber, if you can keep an eye on the drone feed, that would be great. I'll be back just as soon as I can tackle this issue.
Sure. I can babysit drone feed with the best of them. Well, Aurora, once again, I am tasked with keeping the station in one piece. The literal glue that keeps this place together. Wait, what happened? I didn't touch anything.
Specialist Barber, it seems your glue has lost its adhesive abilities in this situation.
Very funny, Aurora. Wait, Aurora, are you messing with me?
I have no idea what you are talking about, Specialist Barber. If you will excuse me, I need to run a diagnostic on the station external sensors.
Yeah, I think I need to run a full diagnostic on you. Someone has been teaching you about practical jokes.
Specialist Barber, I can give you my complete assurance that I am operating normally.
Sure, that's what they all say.
You know, Dr. Schofield, I want to thank you for allowing me to work with you on the development of this new drone prototype. This entire process has been really fascinating.
Oh, Dr. Carafano, the pleasure's all mine. It's so exciting for me to think that a relative of this prototype will one day be used to conduct research on planets far away.
You know, Dr. Schofield, I'm really not sure exactly how drones operate.
Okay, well, drones use rotors for propulsion and control, and the fans actually push air down, which is called thrust. You can think about it like a fan because essentially it's the same operation, but these rotors spin at a rate of about 400 to 500 rotations per second. And as we know, forces come in pairs. So as the air pushes down from the rotor, we get it to push back up as the opposite force.
Now, this is really different than an airplane, which uses wings to fly.
Exactly. And a drone can do 4 things. It can hover, it can climb, it can descend, and it can rotate. Now, when a drone hovers, the rotor's pushing down, or the thrust, goes just enough of a force to mitigate the gravity which is pushing it down. That's how it hovers. As far as ascending, when we increase the thrust, we're overcoming gravity and it causes it to lift. If we decrease the thrust slightly, we can gently bring the drone down. But the most interesting is the rotation. There's 4 rotors, 2 of them move clockwise and 2 move counterclockwise. If we change the speed of one pair by increasing it and reduce the speed of the others, it'll cause the drone to spin.
Wow, that is absolutely amazing. You know, these drones are really a special type of aircraft. I can see why they're so important to scientific investigation and discovery.
Dr. Schofield, I'm so glad I found you. I could really use your help.
Commander Collins, what seems to be the trouble?
Well, as you know, I am responsible for getting the Mars prototype drone operational. The communication link, it's okay. The telemetry data feed, it's operating properly. But the drone, it just will not respond properly. It won't fly.
Huh. Dr. Carafano, how do you think we should begin to help Commander Collins troubleshoot her problem?
Well, as we discussed earlier, in any scientific investigation, the first step is to identify and evaluate what the problem is. Then we create a hypothesis, or educated guess, to determine variable solutions to the problem.
I completely agree. Commander Collins, I think it's important for us to understand about the 3 main factors that affect flight.
So do you mean weight, drag, and lift?
Absolutely.
Dr. Schofield, I would really like to help the both of you solve this problem, but I really don't understand how those 3 aspects are related to how drones operate.
I think Aurora can help. Aurora, please explain to Dr. Carafano about the effect of weight on flight.
Of course, Dr. Schofield, weight refers to the gravitational force of planets and other bodies in the universe, and the effect that this has on objects. In the case of terrestrial flight, weight is what pulls a flying vehicle down to Earth, which is a serious problem for air vehicles which want to stay in the air. To fight gravity, air vehicles like drones need to produce more lift than their own weight to stay in the air.
Aurora, perhaps you can explain to Dr. Carafano what is meant by lift.
Lift is the sum of all the forces of an object, like an aircraft, that allow it to move in each direction in relation to the direction of airflow. Normally, in this context, lift is considered an upward action allowing the aircraft to fly. However, lift can be in any direction. For example, for a sail on a boat, the lift is horizontal, and for the spoiler wing on a race car, the lift is down.
Thank you, Aurora. That makes much more sense now. But how does the concept of drag have to do with all of this?
Drag is the force that slows down objects as they travel in air. It is also known as air resistance. It is a force that is caused by air. The force acts in the opposite direction to an object moving through the air. It is where air particles hit the front of the object, slowing it down. The more surface area, the more air particles hit it, and the greater the resistance.
Thank you, Aurora. That was very good. Now that Dr. Carafano has a better understanding of those three aspects, I think we should put our heads together and figure out how we can solve this issue.
Well, we do know that the drone itself was tested and functioned properly here on Earth.
However, now we're trying to operate this drone on the planet Mars.
So perhaps we need to think about the atmospheric conditions on Mars. Aurora, can you tell us about the atmospheric conditions on the planet Mars?
Of course, Dr. Schofield. The atmosphere on Mars consists primarily of carbon dioxide and has a significantly lower atmospheric density, only 1 to 2% of Earth's atmosphere. The atmosphere on Mars would be equivalent to altitudes of approximately 100,000 feet on Earth. In addition, the Martian gravity is approximately 38% of Earth's gravity. Therefore, if an individual weighed 100 pounds on the Earth, they would only weigh 38 pounds on Mars.
So, we know that the weight of the drone is considerably less on Mars than it was on Earth. But the air is about 100 times thinner, so we will need more propulsion to lift the drone.
So, since the Mars atmosphere is about 1 to 2% of the Earthly's air pressure, that means it'll be about 50 times harder to get the drone to fly on Mars than on Earth.
Dr. Schofield, how are we going to get the drone to produce more lift?
Well, if we think about the rotors and the rotors spinning, we know that the faster they spin, the more lift they'll provide.
So that means if I can increase the speed of the rotors, that means I'll be able to get the drone to lift properly.
Just like on the fan that we talked about earlier, the higher the setting, the more air it pushes.
Oh, so that's how we can compensate for the thinner atmosphere.
So, Dr. Carafano, I'm glad you understand that. So now that we know that we can increase the propellers even faster than what we're doing before, that will help us resolve the problem.
Amazing. Well, Dr. Schofield, I think you've got the problem solved.
Glad to help.
I'm going to head back and go ahead and get this fixed. Hopefully I'll be able to stop back and tell you guys what we resolved and how it worked.
Good luck, Commander Collins. You know, Dr. Schofield, it's amazing how much you have to know and understand to operate a drone properly, especially on another planet.
Drones are absolutely the future.
Yes!
Commander Collins, you look like you're really having fun now.
Well, you know, I contacted NASA and they were able to help me to compensate for the Martian atmosphere. So I found out that our Mars drone, it weighs on Earth 4 pounds and has a wingspan of about 6 feet. So what that means, I had to make the rotators go faster, about 2,400 revolutions per minute. So everything is all great now. Everything is operational. I've tested everything and we are ready to go. The Earth scientists will be prepared to do their research.
That's great news. Perhaps at some point later you can teach me how to fly a drone.
Specialist Barber, I do not think that would be a good idea.
And why not, Aurora?
I think that Commander Collins' instructions would just go over your head.
Wait, Aurora, did you just make a joke?
That was funny.
Specialist Barber, I also think you should reconsider learning how to fly a drone. I have heard that drone pilots are considered snobs because they look down on everyone.
Commander Collins, did you put her up to this?
I'm not going to say a thing. I do not want to incriminate myself.
Did you hear about the store that sells sentient drones? They're flying off the shelves.
That was a bad one.
What have I gotten myself into?
This concludes our latest episode of SpaceGate Station. Please join us on our continuing adventures as the crew of SpaceGate Station provides engaging enrichment or remediation-based instruction to improve your understanding of science, technology, engineering, and mathematics, terminating communication with Earth